Hey guys, Sam here. How's it going? Started reading a book lately, one about zombies, about the end of the world and all that, and got me thinking. We seem to be pretty obsessed with the end of the world and our own extinction, and we come up with a lot of oddly fun stories about it. But the thing is, they're all about zombies that were caused by science gone mad, or ancient prophecies causing the world to self-destruct, and they don't really do a lot to tell us what might actually happen when the world ends, or how it might actually happen. So what I want to know is, how's the world really gonna end? Well, first we have asteroids. They could be a real day wrecker for us. In 2004, we discovered the asteroid called Apophis. It's about 325 meters wide, and if it hit the Earth, it wouldn't really end the world, but it would do a little bit of damage. Now, it flew close by to us in 2013, and we got a really nice chance to study it. And it's going to fly past us again in 2029 and 2036. And originally, scientists thought that there was a maybe 2.5% chance that it might hit us on one of those occasions. But as we've learned more about its trajectory through space, we've pretty much been able to rule that out. It will come pretty close, though. It's going to pass within about 19,400 miles of the Earth's surface, making it the closest near-Earth flyby of pretty much any object that size that we know of. One object that did hit us recently is the object that exploded over Chelyabinsk in Russia in 2013. Now, that was a relatively small asteroid, but when it hit us, it still managed to explode with more force than a nuclear bomb. But while Apophis didn't hit us, and most likely never will, and the object that hit Chelyabinsk did minimal damage, there could still be large objects in outer space on a collision course with the Earth. That's why NASA's committed itself to locating every near-Earth object, or NEO, that it possibly can and that could threaten Earth. NASA's even issued one of their grand challenges to do just that. Keep in mind, we know we've been hit before, and we know that it's caused a lot of damage. The Chicxulub impact off the coast of the Yucatan Peninsula 65 million years ago caused the 5th mass extinction event that we know of, also the most recent one. It's the one that wiped out the dinosaurs and a huge number of other species on the Earth. But that isn't even the biggest mass extinction event that we've ever suffered. 250 million years ago, the Permian-Triassic mass extinction event wiped out 90% or more of all species on Earth. Now, scientists think that it could have been caused by an asteroid as well, but there's really no proof of that, and there isn't even a crater that we know of that corresponds to that timeline. Another possibility for what caused the Permian-Triassic extinction is that it could have been caused by volcanic activity. Oh, that reminds me. We've also got a killer volcano that just might get us. Yellowstone National Park is home to a volcano, but it's not just any volcano, it's actually a supervolcano. Now, a supervolcano is any volcano that's had a past eruption measuring at least a magnitude 8 on the Volcano Explosivity Index, meaning it's ejected at least 1,000 cubic kilometers of deposits all at one time. Now, Yellowstone's erupted 3 times in the past. Once 2.1 million years ago, again 1.3 million years ago, and most recently 640,000 years ago. And Yellowstone isn't alone. There are supervolcanoes around the world in places like New Zealand, Japan, and Indonesia, just to name a few of the ones that have blown their tops in the last 2 million years. The last time Yellowstone erupted, it ejected more than 330 cubic kilometers of ash alone. Now, if that happened today, it could start causing some problems because some places in the US might be covered in as much as 40 inches of ash. Now, the reason that causes problems is because it starts to weigh down on roofs, and they're really not designed to hold up all that extra weight. That's why you start to see things like roof collapses that can really start to hurt a lot of people and damage a lot of property. Not to mention the potential devastation caused by a volcano erupting with more than 2,000 times the force of the Mount St. Helens eruption in 1980, which itself turned a couple hundred square miles into wasteland. Some people think we're due for another eruption any time now, and there certainly is a lot of activity going on at Yellowstone. The magma chamber has around 15,000 cubic kilometers of magma in it, and the ground around Yellowstone has had temperature increases, ground swelling, and seismic activity. But lucky for us, scientists aren't so sure about that. As it turns out, it's kind of difficult to determine when, if at all, another eruption might occur. And while there is a lot of activity going on, for all we know, that's just normal operating procedure for a long dormant supervolcano. Some scientists say that the chances of another eruption occurring are akin to us getting hit by a very large asteroid, because it's not like that's ever happened before. Okay, so say we manage to avoid any giant wrecking balls from outer space and no more supervolcanoes decide to go supernova on us. What else out there could get us? Well, actually, as it turns out, a supernova could do the trick quite nicely. Supernovas come in two different types, creatively named Type 1 and Type 2. Type 1 supernovas occur when a star steals matter from one of its neighbors until a runaway nuclear reaction occurs. Type 2 supernovas occur when a star nears the end of its life, runs out of nuclear fuel, and collapses on itself under its own gravitational weight. Both of these result in a large explosion, one that's big enough to obliterate any tiny blue planets that might be nearby, as a matter of fact. A nebula is usually all that remains after one of these supernovas. The good news is that there are no stars nearby us likely to go supernova, and even if they did, it probably wouldn't affect us with the blast. But even so, supernova, even one from another galaxy, could still get us with something called a gamma ray burst. Now, a gamma ray burst is exactly what it sounds like. It's an intense burst of gamma rays, focused into a narrow jet and emanating from a supernova. If we ever took a direct hit from a gamma ray burst, our goose would pretty much be cooked. We don't know of anything else in the universe that releases as much energy at one time as a gamma ray burst. And because they travel at near the speed of light, we'd most likely never see it coming and never have any idea of what was about to happen to us. Not that that would do us any good. When it hit the planet, a gamma ray burst would destroy the ozone layer, exposing all life on Earth to intense UV radiation from the sun. And it would also deliver as much energy in a couple seconds as our sun will have put out by the end of its 10 billion year life. And if that weren't bad enough, when it hit us, it would probably just irradiate the whole planet. And it turns out that just like volcanoes and asteroids, gamma ray bursts may have done some damage to us in the past. The Ordovician mass extinction event is the earliest known on the Earth, and it occurred 440 million years ago. The reason why it's important is because it may have involved gamma ray bursts. But perhaps the scariest thing is that we don't really need asteroids or gamma ray bursts to wipe out everything on Earth. As it turns out, we're perfectly capable of doing that on our own. The Doomsday Clock was created in 1947 by the Bulletin of the Atomic Scientists, largely in response to the advent of nuclear weapons and the political strain between the United States and the USSR. Midnight on the clock is supposed to represent the end of the world, so in theory, the closer the minute hand is to midnight, the closer the entire world is to total annihilation. According to the Doomsday Clock, the closest the world has ever been to total destruction was 2 minutes to midnight in 1953, after the United States detonated their first hydrogen bomb, and just 9 months later the USSR detonated their own. The furthest we've ever been from total annihilation was 17 minutes to midnight in 1991. The reason for changing the clock all the way to 17 minutes to midnight was because the Cold War had just ended and there were hopeful beginnings to nuclear disarmament. As it stands, the Doomsday Clock is currently set to 3 minutes to midnight. There are more than 16,000 nuclear weapons in the world, and 1,800 of them remain on high alert, ready to be used at a moment's notice. We have more firepower than we would ever be able to use. That's because we only need a fraction of what we actually have to annihilate everything we've ever known. On top of all that is climate change, the other reason cited for moving the Doomsday Clock ahead to 3 minutes to midnight. Every day we're pumping more and more greenhouse gases into our environment, and the symptoms are starting to show. Rising global temperatures, increasing sea levels, and increasing levels of acidity in the oceans are just a handful of those symptoms. We could be entering a sixth mass extinction event, one brought about by human activity. By the year 2100, as much as 50% of the world's species might be extinct as a direct result of our activities. And if we are in the beginning stages of yet another mass extinction event, we might be one of the species that goes. We're pretty smart, but our technological know-how just might end up being our own undoing. After all, it seems like it's the top dogs that always get hit hardest during these mass extinction events. Take for instance the dinosaurs. They're not around anymore, and we're only descended from the smaller mammals that just managed to scrape by. But hey, just because all this can happen doesn't mean that it will, and even if it does, that doesn't necessarily mean that it'll be the end of the world or the human species. Maybe we'll get lucky, maybe our little blue planet will stick around forever and we'll always be smart enough to find a way to stick around with it, right? Well, actually that's not possible. Assuming we don't get obliterated by any large objects in space or wiped out by any gamma ray bursts, and also assuming that we don't just annihilate ourselves in one big nuclear fireworks show, eventually the sun's gonna die. It's gonna take 4.5 billion years, but it is happening, and when it does, we're going with it. You see, as the sun nears the end of its life, it's gonna start expanding bigger and bigger, until it's about twice the size as the distance from Earth to the sun now. and then it'll eventually blow away all of its gases and leave behind just a core called a white dwarf, which will exist for a much longer amount of time. But in the process of that, the Earth is going to be swallowed up and destroyed. There's no way we can stop that from happening, but we can try to escape it. We can leave our solar system behind and make a new home on a new planet orbiting a new star. And we can keep going on there long after this world is over. But eventually, there's no escaping the end of everything. The death of the universe. One of the ways that the universe could theoretically end is called the Big Freeze. Now this is where the overall temperature of the entire universe gradually approaches absolute zero, or 0 degrees Kelvin, without ever actually getting all the way there. You see, eventually there isn't enough gas clustered together to start creating new stars, and after a while the entire universe becomes dominated by black holes, and there's not really a whole lot else around. But given enough time, even those black holes begin to dissipate and eventually disappear entirely due to Hawking radiation. This is going to take a very long time though. Another way that it could go down is something called heat death. In heat death, the entire universe reaches maximum entropy, essentially meaning that there is no difference in any energy anywhere in the universe. Everything is uniform. It's those differences in energy which are required for information processing. Information processing is the change of information in ways which can be observed, so everything in the universe. Once we've reached maximum entropy, the universe is essentially dead, and so is everything that is or was a part of it. Entropy's a bitch. So in the end, we can try our best to ward off the end of the world, but really, it's the end of the universe that's gonna get us, when everything just kind of stops. So, I guess all we can really do is make the best of things while they're still around. Thanks for watching.